like this. So roughly this is the plan. If we will take a little bit longer, I will try not to make it more than 2.5 hours, 2 5-minute breaks, and roughly 2.5 hours of content.
Okay.
It really depends how we go. We might finish earlier, but in general, I planned 2.5 hours of content.
Okay, that's great.
So, do you see my screen?
I do.
Okay, good. So this is important. I will close the other
Mm.
screens, and I think we can start in 10 minutes. So for everybody now and later, all the materials are on a public Google Drive. So all you need is this link, nothing else. And I will put it to chat of the DSC. I'm just closing all the windows. So what you have in this folder is you have a little bit of cheat sheets for those that didn't use these libraries. They're really nice. You have a small overview of what you can do with them. I also put inside these slides in PDF format. So if I go faster over something, you will still have slides. All the code plus couple of key books if you are interested in such topics. So maybe Tableau you will not need in this one, but for sure you will need these ones. So this is classical book of Stephen Few on dashboards, classical book of Mr. Tafte on visual quantification of data, and one really special book which I really like is from Scott McCloud, is how to understand comics. It's not connected to business itself, but shows a lot of concepts of visualization and explains how actually comics are created. It's an applied science of data visualization. So if you like something like this, you will find it in my shared folder.
Mm-hmm.
So it's we should start in 1 minute.
Yeah, I'll do a short little introduction and then I'll leave it up to you.
Please do the introduction. Stage is yours.
Okay. Hello, everyone who's joined us now. I'm just going to let a few more people in so they can ask questions. My name is Miloš. I'm the project managing assistant for Data Science Conference in general. And right now we're at Data Science Conference Austria. Josip Saban is going to do our second tutorial on this track for today, which is on data visualization in Python. He's going to be using few popular Python libraries like pyplot, seaborn, plotly, etc., as he will further mention. One quick thing, as I've already mentioned, it starts right now, and there is a 2.5-hour slot. Josip has all the freedom to organize the time however we want, with breaks and stuff like that. One thing that I would mention is that you guys keep muted during the presentation, as I'm sure Josip has accommodated the questions, and basically he will be leading the way how you can jump in and ask questions if something isn't clear. So without further ado, Josip, you can take the floor.
Thank you. So welcome all of my 15 attendees at this moment. Nice to have you. For the next 2.5 roughly hours, we will discuss the topic of data visualization in Python. I imagined this lecture in a format like this, basically, and I will start sharing the screen again. So This is basically the format I want to use for today's sessions. So there will be an introduction of 30 minutes plus 15. First 30 minutes will be introduction to data visualization, and I will go quite quickly over this one because I believe that a lot of you already know these things. If you do not, or if I go to some topics fast, all of these slides are in the Google Drive. Link to Google Drive is here. It should be public. If you cannot access it, let me know, but it should be public. Next 90 minutes we will spend in Python, and we will go to four libraries. We will go to usual matplotlib seaborn with a small intro of what is possible with an EDA, so initial stage of data analysis phase with a small demo. And then we will go to Plotly, which is not so often used, but actually quite powerful library, with an last topic of advanced data science visualizations, where we will use graphs and visualizations, which are not that standard. For any questions, topics, technical issues, please ask or raise a hand. So I will try to do something to see if somebody has a question, maybe something like there is a chat where I can find the files. Barbara, on the link. I don't know if you see it. You joined later. So I'm copy pasting again. Maybe you don't see the history. So it's on the Google Drive link. I don't know if, is this link now visible to you? Bye-bye. Is it okay? I don't know who is seeing this copy. Okay. Wait, who can see your messages? Everyone. I think now should be visible, right? It should be okay now. Cool. So the PowerPoint. I will go to a little bit of TA, but if you, I will somehow do it that I always see this chat here and maybe a little bit minimize. So if somebody writes something, I will see it. You see my screen. If the screen is too small in any way, let me know. I can do the full screen, but this is just that I see your questions. Who am I? I finished uni in Zagreb in 2004. Then moved from consulting to having a startup, and then moving to working at the moment for Erste Digital in DVH in Vienna. What I do BI for last 10 plus years, focusing on standard data warehousing, and last 1 or 2 years on data visualization. I'm a Tableau coach. I do Power BI from the day that Power BI went to the market. And in the last 6 to 7 months, I'm trying to apply the concepts to Python. What I do, and if you're interested in other things, there are links in the end. So you can aid on GitHub, you can contact me on LinkedIn and such topics. Why this lecture? Why is it interesting? You cannot do anything without visualization. And in the old days, Excel gave a really bad name when people created terrible graphs and charts using the Excel. And we got used to the fact that visualization is, well, basically that it sucks. And this is our feeling until last 5 to 10 years with development of data science and machine learning. It became again a focus. What is important to say, it's a separate field. You don't do it on the side. You don't just click in Excel, create me a pie chart or a line chart, and you are the expert. You have to know a little bit about TA if you want to do it properly. To enable you learning properly, meaning reading a couple of key books. These key books are again in the share drive. Like I mentioned before, one of them on dashboard design, which is a separate field, and the other one is from Tufte. The book from 2001, so almost 20 years old now, but still, this is the main book of these things don't change, in short. Sorry. So we start with what? We start with 5 topics, and this will be before the break after 45 minutes. Now, if you can see my screen, you have this, you see that the number of slides is amazing. So I have 71 slides. But this is what I said. I will go through them a little bit faster because I think that most of the audience on this conference is already know, but just to put everybody on the same level. If I'm too fast for somebody, use my materials. So I will go now to full screen, but I will come back to chat if there are any comments. So, human visual perception. Human visual perception is a very, very hard thing to evaluate unless you know a few basic rules. One of the basic rules is that most powerful sense is visual. If you would not have sense of smell or a sense of hearing, you would be limited as a person, but without eyes, you are you cannot function easily as a human being. All the other things are handleable. Being blind would be extremely limiting. And to accommodate this and to accommodate the fact that we receive an enormous amount of data through visualization through the eyes, we need to know a couple of basic rules. The first one, what works, second one, what doesn't work, and third, why it works. And this will define is your visualization in the end effective or not. So what works? And I will discuss a small part, so patterns. Our brain sees in patterns. If you see before you, you will see probably a monitor, keyboard, mouse. These are all patterns. Your mind has to distinguish between an enormous amount of information it receives over what is important in recognition. This is the same with visualizations. This is called pre-attentive processing, and this is used to detect a specific set of attributes. These sets of attributes can include things like color, shape, distance, form, and it is immediate. If you turn your eyes, you will immediately recognize a lot of things which you can define by color, size, or distance. But if you are doing something which is sequential, reading a book, analyzing an Excel file, it is called attentive, which means you need to focus and your mind cannot do it let's say using the usual evolution engine. It has to focus and use the things that it learned over the time. Let's demonstrate. This is a very famous demo. I think most of you saw it before. And this you probably got in the old days on HR interviews. You would get a list of numbers, words, letters, and they would tell you to count them. And in the usual test, you would get 20 to 30 seconds, and I would tell you count 3s, 5s, 6s, whatever. Your brain cannot do this pre-attentively. It cannot do it by form, size, shape, or color. It has to count. This is like reading a book. It's extremely slow and it's extremely tiring. Let's make one more change. Just paint 5s in black. Your job is now trivial. You can do this exercise without using any effort on your brain in about maybe 10 seconds, even less. If you have issues, as it says in Zoom, but I have a lot of resources here, please let me know on the chat. Now, with a small change in your visualization, just allowing your eyes to recognize a difference in the pattern, so black against blue, you manage to process a very hard attentive task in a pay attentive way, because your brain recognized the difference and it counted differences, not the number fives. So what was the review? Fives could be easily distinguished. Why? Because they are different by color. Where does this come from? Where does this entire story of difference comes from? It's very simple. It comes from evolution. It comes from the fact that in the old ages, when we were in the caves, we still needed to hear sounds, we needed to hunt, we needed to see fire. And our brain over tens of thousands of years learned to recognize differences. And this was survival instinct. This didn't change. And this is one of the key features in proper visualizations you need to use to say what is important, not to write, not to circle, make it different from other things. This is lesson 1 of importance. Why did we have a difficulty? They are not something we can perceive pay attentively. Simple shapes, such as circles, are pay attentive. Why? Because we teach them from day one. When somebody taught you how to write, you would learn these kinds of things. You would know what is a circle, what is a square, and this is why the best visualizations are simple, because they are used to. There are 4 categories: color, form, spatial, and motion. And this is again from our birth, from our evolution. We distinguish easily between colors, we distinguish easily between form, distances, and are objects moving or not. So, what else can we understand easily? Sizes. We can say that object on the left is smaller than the object on the right, but we do not know how much. Our evolution and education allowed us to compare sizes, and we can say that the object on the left is smaller than the object on the right. But if I would ask you how many times, you do not know. Again, you would have to attentively count. You want to give your audience the effect of 2 items which are bigger and smaller, but don't force them to count. If you want to show how much, this is not a proper visualization. Apologies. There are 4 principles. And if you hold to these 4 principles, you will have good visualizations. There are proximity, closure, similarity, and enclosure. And again, this is by evolution. Principle of proximity. I'm not reading you the text. You can read it later. I'm showing you the end. If we group objects together, even if they are not related, you will consider them a part of one same group. If you separate them, your mind will pay attentively, think that this is the same group of items, but somehow differentiated. We have soccer players in a game and we have attackers and defenders, but they are still in the same team. Then we have separated 2 distinct groups, and we have separated 2 groups of similar things, but with some exceptions. If you want to show things, for instance, we have 2 distinct groups, but paint them in the same color, you will have to fight what your brain implicitly is telling you, and that this is a same group with 2 subgroups. If you want to present 2 distinct groups, you have to paint them differently. Yes, you can explain with your words or with your text what you actually want to show, but the impact is lost. Second topic is closure. If you do not close your visualization, your mind will think that the topic is not closed. Do not go into the essence that this is nice to look at. Don't fight the brain. You have a keen dislike for loose ends. I will not listen to what is written inside. I will not even care about the content. I will care to understand why do I have a hole, or in this case, 2 holes. And if I, as a presenter, start to discuss what is inside, my audience will not actually listen to me until I explain them the hole. If this is like we are 90% done with the process, and thank you, dear audience, we still have 10% of the project to continue, then this is a good visualization. But if we are saying we are done with this task and leave a hole, there will be a part of our brain that will fight this idea. Third topic is similarity. Your brain looks for patterns, and they are in the size, shape, and orientation. I do not have to tell you anything about this visualization, but you do know the story. These are 2 distinct classes. These are bigger and smaller items. These might be, I don't know, master detail relationships. These can be multiple categories of the same validity, and this can be, I don't know, something which is in the same group but behaves erratically or chaotically. Again, I did not have to put you any text, any description. Your brain recognizes this. This is how good visualizations are made. If you want to show a chaotic state of a project with multiple tasks, you do not use this kind of visualization like good state, bad state, because your brain will not recognize. You use something like this. Do not fight evolution. And the last one is enclosure. Enclosure is a concept that if we draw complete boxes, you will inherently think that they are different categories. Do not do it in this way if you do not want to show this. Again, consider that these are numbers or these are some kind of data points. But what do we have here? We have here implicitly taught 2 main categories with similar points inside, and 1 subcategory which is separated from this one, but is part of 1 of 2 main categories. I'm showing it by circles, but they can be any kind of data points. Show exactly to the audience what you want them to see. Don't force them to fight. And these are some closing thoughts if you want to read. I just said it, but if you want it in the material, you can read upon it later. There is 2 points on this slide I want to specify. First of all, animations. People like animations. People like things to move, but they're actually quite annoying. Because if you have an animation, your entire audience will look at that animation and not listen to what you are saying and not read your message. If you have a nice cool guy jumping up and down, then you have an issue because nobody will listen to you. Nobody. Then, don't fight the brain. Do it in a way that brain prioritizes, or you will have people who will look at a slide or a visualization and not listen to your message. This one is a topic of the book I gave you to read about. This one, the Tafte book. And out of Tafte book, I took out a very, very small subpiece. This is data ink and charjang. There is 8 or 9 categories. These are, let's say, the most visible ones, but not maybe the most important ones. If you want to learn more about data visualization principles, read the book. I will just cover 2. First one is data ink. And data ink is the amount of useful data that you see on any kind of visualization, either a slide or a Python chart or an R chart or whatever. And there is an exercise which we don't have time to do, but you can do it easily by yourself. I have an example here, but there is a much nicer exercise, and I will use the best presentation tool ever, Microsoft Paint. And I will try to show you your usual slide. You were all working in some company, then you have a company slide. This is your slide. And on your slide, there's usually 3 points below. Here is some kind of logo. Here is some kind of disclaimer. And here is some kind of page number. On top, you have a header. And usually on the right side, you have again some kind of logo. And you have some kind of useless thing here. How much data was just lost and your audience gained nothing? Disclaimer, maybe you have to have it, but is it actually useful except on the first slide? Logo of your company, you can also put it on the first slide, but is it actually useful on all the other ones? Page number, does anybody care except the presenter? Logo, same story like here. Header might be important, but might not be. And usually this is 15% of the slide. This is 15% of the slide. And if we stay, there is 70% remaining. 30% is what is called in the professional data visualization is char junk. This is uselessly spent area of presentation. You cannot remove it completely, but you are losing 30% of something which you can use usefully. Think about it when you next time create a corporate or a powerful presentation. What your audience wants to see, page number, disclaimer, logo, probably not. And then we have a very famous example of Data Inc. And this is two of them actually. One is brain activity, a very long word. But it shows exactly what a doctor wants to see. It shows the brain patterns in 5 categories: excited, relaxed, drowsy, asleep, and deep sleep. It gives you a timeline, 1 second. Nothing more is needed. No headers, no logos, no status bars, no manufacturer logos, no disclaimers. This is a perfect data visualization. It shows to the audience exactly your message and what they need to see. Second one is an upgraded format about body mass in kilograms versus brain mass in grams. Over history, over different kinds of animals or creatures. And how it started is actually like this. This is what Excel provides for you. You have X's, Y-axis, and dots. This is completely useless. What happens if you go over with a mouse? There will be a pop-up and it will give you details. But this is completely useless. You have a chaos. You do not know exact values and you have no details. Then what tools will do? They will create you a help. They will put labels. And these labels do not add much to the story, because if I'm looking for a gorilla, I actually have to go to entire slide, look at it, read it, and I still do not know the exact numbers. And all I got is dot. What takes much more effort, but gives you a message, is to replace the bullets and labels with animals. You will still not get the same info, how many exact body mass kilograms versus the brain mass in grams is for human, male or female, but you see it visually. You do not, you can understand, pay attentively. You know that this is a lion, you know that this is a gorilla, you know that this is human, you know that this is an human ape developing into a human, blah, blah, blah. You do not have to read. How much time would it take to take into your mind this one versus this one? This is produced by Excel or any other tool, this one or this one. Not for every presentation you need to be this specific, depends on the audience and importance of visualization. But this one maximizes the data. There is no junk here. Next topic is child junk in marketing. And this is usually when you are using all the features of the tools unnecessarily. So what I want to show is a TED talk. We all know what are TED talks, and this is real data. And this is a percentage of how people are talking on a very big data set. And this is okay. If you want to see a percentage, a little bit of text. Even this is borderline okay, although a lot useless TD. But then you get this one. What is this? This a fancy tool can produce. But let's say we close this 49%. Do we get any useful info? Our pink, orange, and yellow seem basically the same. Is this really 2.5 times bigger than this one? Is this one really 2.5 times bigger than this one? Do we even care? Does this visualization bring any value to the story? No. This one can be done much better. This is useless, and this is the data. So do not, the message here, this is complete child junk. Yes, your tool can provide something like this, but to the end user, it brings nothing. And now we go to the corporate world. And in the corporate world, we have something which is totally cool. We have people who try to add things as much as they can on one slide. And this I see daily. You have a slide with a project which starts from day 1, ends at day 100. And then they put timelines, they put people names, they put labels of description. And you get something like this out. What is the message? Nothing. I have to read. I even have details below. I have something which is okay visually, but I actually have to read. But what is my message here? If I want an impact that something is a problem, then this kind of thing keeps the audience in. I need to interest my audience in my visualization. This does not interest me. This is just a lot of text with some slides. This one gives me immediate message. We know it's about heart disease. We know it's women. We know it's United States. And we have a main message: 1 in 3 women's deaths are cause of heart disease. Yes, we have some child junk here and here, but it's not major. Our audience immediately know what we will talk about. If you want detailed info, you can do it differently, or it's not on PowerPoint. But this is a message. And I'm just trying to, now I didn't want to take it from any kind of close industry, but this is what you see in corporations every day. This is useless. This brings nothing. This is something which has a lot of text, lot of labels, something similar, more description. You do not do it this way. You do it simple and with some kind of workflows or details or something. I'm at this moment showing you child junk, and then we will go how to do it properly. Same here. What do we see here? Age is not a dividing line. Millennials report similarly high levels of caution. We still don't know what we are talking about. Then we have some child junk, that we have some BCG, then we have a long note, and then we have a text and a flag. What does text and a flag mean? Either we have educated people in the audience which know that this is a flag of UK, Germany, or Spain, or we do not, and the flag doesn't bring anything. So we either keep text or we keep flag. Both of them are child junk. You do not need both. And the last one, which I had to take, of course, not from the real world, is a usual project pipeline something. I found this one on Google. But it really shows how people present. And consider that you are first time looking at this. Do you understand anything? No. The guy really, or the person really tried to put everything on one slide, but the amount of information here is overwhelming and you get lost. And this is the effect your brain suffers. Too much info. I need half an hour to analyze what is on that Excel or on this visualization before I can do anything. That means the guy who did it failed. And some closing thoughts, you can read them later. I said most of them. Now, next topic, graphical form. On this graph, I could stay a long time. This is a very famous one. This is Napoleon's travel from Kowno in Poland to Moscow in his biggest defeat, where he basically lost entire war. If you want to read this one, this is quite a figurative. It lies in Louvre today as the best data visualization from history. But this thing actually implements all the principles we'll discuss today. It implements almost no chart junk. This had to be there for historical reasons, this text on top, but it was added later. In the initial version, there was no text. You only had this one. The depth of the line shows how many soldiers started from Poland, 422,000. This is his way to Moscow as people died. This is the separation of the army. This is a big battle. They lost it. They came to Moscow with only 100,000 people. So along the way, 322,000 people died. And then the winter came, and then the military started going back, joined by the lost forces. So it increased in depth, and they turned back to Poland with only 10,000. And out of this graph, I do not need to explain you anything except the basic context. You will understand everything. Locations of main battles, locations of main areas, important at that time. Longitude and latitude, we didn't have GPS coordinates at the time, and the temperature. The temperature on the retreat of the army was -20, -24, -30, so the usual winter of Russia. And that's it. I can tell you this and be quiet. And you will see on one visualization the entire history of war. This is the ideal data visualization. And the last thing, or almost the last thing I will mention, is what you want to achieve with data visualization. You want to achieve comparisons, you want to achieve changes, reveal hidden relationships, and envision or predict, in machine learning language, temporal or spatial patterns. And try different forms. Now, you might think that you know everything about visualization, but actually you do not. Nobody does. And one person made a really famous website. It's called Data Visualization Catalog. And he created an archive of, let's say, all the possible things you can do, categorize them. It's completely free. It's part of his PhD. But there is one key feature on this site. It's called search by function. Not view by list, search by function. And it gives you proposals how to visualize certain business aspects. Business presentation, data present, whatever. There's a lot of functions here. Below each of these boxes, there are dozens and dozens of visualizations. But search by function allows you to answer a key question. How do I visualize this problem? Use this site. It's really cool. Now I will mention just a couple of the usual visualizations. I'm good with time. And we are on half of the PowerPoint. And I will comment them, but not maybe in the usual comment you're used to. So first of all, I will comment the pie chart. So as everybody is online and I see the thanks, any questions, any technical issues? Okay, as you see, please write if you have anything. I have the chat screen open. So pie chart. Pie chart is originally made to display parts of the whole. You have multiple categories and you have parts of the whole. It's actually extremely bad tool. It's an extremely bad visualization unless you want to show how many categories are in the whole. But if you want to show which one is bigger, then it's an extremely bad visualization tool. Because you cannot visually see the amounts. So this is a small take, 44% of scissors, 33% of paper, and 22% of famous American game. But if I would remove these values, 44 and 33, would you actually think that this gain part is that much bigger than this gain part? In reality, if I would remove you the labels, they would look almost the same. And this is used in two perspectives. One, when you do it badly, so your audience needs to read. And secondly, and this concept we do not have time to go into detail, is when lying with data. So giving false presentation, but showing correct numbers. And this is when you want to hide that your competitor is very close to you or that you want to show that your result is so amazing. Then it's called lying with data. There is a whole chapter in the books which I recommend. Pie chart is very dangerous. Just use it when you want to show the number of categories, but not comparisons. If you want to use, don't know how to use them, use something which is called a tree map. Tree map is very efficient graph, and it's supported by most of the tools, but shows in a much better way categories, segments, and sizes. Again, you do not see exactly, but pay attentively. Your brain sees that the dogs take probably, but this is probably 60% of everything. And your brain doesn't fight this. Again, you do not see exact values, but compare this and this. This is easier to read. You have distinct categories by colors, so play. And if you do not know which visualization to use, go back to Mr. Rebecca. Then, do not give your end users more than they need. This is a normal budgeting graph. We have incomes, we have expenses over month with some amounts. Then we put a line where we put an average income, and then we put a line where we have average expense. This graph tells me as the end user that I have no idea to which audience I'm presenting. If I'm a CFO, I do not care about something which is not summarized. Do I really care that in January I had 4,000 of expense and 5.5 of income roughly? No, as an CFO, I care on the difference. But if I'm an analyst, I would care about both of these. And then to fix this idea that I do not know to which audience I'm presenting, you put an average. Average means nothing. Average hides everything that's not in the average. It's not for analysts, and it can give fake information to CFOs. This is a simple graph which shows that you didn't know who is your audience. Plot what you want to show. If I'm presenting to CFO, give me a difference between income and expense. If I'm plotting to the analyst, I do not need averages. I will calculate them as an analyst if I need, but I do not need them. And this is the topic of integrity. And this one I always like to show is two concepts. First concept, if you have garbage in, garbage out, it also applies to data graphs. And this goes to the one of the basic concepts of data science is correlation, causation, and you probably all know the story. But the same story, like you know with data, also applies to graphs. There are two categories here. You are spending on science, space, and technology, and hanging strangulations and suffocations. If you put them on a graph, you can state by only looking at this graph that if you invest more in science, more people will kill themselves. This, of course, makes no sense, but you can show it by showing it on a graph. If it's garbage in, it's also garbage out, however good it looks. And the second quite famous example is Earth yearly average temperature. And there are two types of people. There is no increase in heat. And there is, and we will all die in 100 years if we don't change everything. These are the two sides. Of course, the truth is somewhere in between. But if I want to show in camp 1 that I do not believe that there is any increase in temperature, and this is correct data, but there is a problem. Look at the Y bar between 0, 10, 20, 30, 40, 50. If the temperature ever reaches 20 or even lower, we would all be dead. There would be no human life. But why did he put 50? Because he wanted to show on a big Y scale that there is no change. And actually, there is no change if you put a scale like this. And this is called misleading time series charts, because over time, it looks like nothing is changing. But actually, there is, he just on purpose put the Y-axis too big. So let's try to fix this story. We are now putting from 0 to 15. Now, there might be a change, and 1 degree in Earth year temperature average is actually an enormous change. But he can still say, yeah, maybe in 12.5, this is like 13.5. Yeah, maybe it stayed about the same. I don't see exactly, but it's less than 15, more than 14. Maybe these people are talking bullshit. It's not that important. But on the other hand, we still have an area between 10 and 0, which will never happen. We don't need it on the graph, and it still puts the graph too flat. So let's make another change. Let's start with the real minimum and maximum. Start from 13.5, which is, let's say, almost minimum value, and finish with 1475, which is a maximum value. Now we see some major changes. Now we are not lying anymore. Now we see that before or in the beginning of industrial evolution, average temperature was around 1375. But in 2012, when this is the last data in this data set, it was 14.6. The difference in only 40 years or 30 years, 35 years, which is nothing, 200 years, which is 130, which is nothing compared to the age of the planet, is actually an increase of almost 1 degree. Now compare this message to this message. No change. Change of almost 1 degree. Why this happens? We can say it's human touch, it's in its normal Earth change of temperature, but the why is not the issue. What we showed is no change versus enormous change. Both data visualizations showed same data. The guy was not putting false data here. He just hide it with misleading time series. And put it even more, put from 1964 to 2012, and the growth is even more substantial. You have it from 13.8 to 14.6. So in a period of 1 lifetime, the temperature increased almost 1 degree. It's huge. Why? I will not go into because I do not know, but the message is it happened. And of course, the famous machine learning topic or data science topic, which also applies to data visualizations. Correlation does not imply causation. Railway train collisions and US crude oil imports from Norway. The fact that we are importing as in US more or less crude oil does not imply that there will be more or less train collisions. This is a, don't connect things which are not connectable. One thing that people in marketing like to do, and then maybe we will make a short 5-minute break before I start with the last topic of dashboards, is this 3D principle. And 3D principle or dimensionality principle is this one. There are correct numbers, 146, 159, 153, 178, but forget numbers. What does it visually mean? It looks like that this corn yield product is enormously better than everything else. It's in red, it's put in front, it looks bigger, and it's bold. When you look at it like this, it's enormously better. But if you analyze the real data, the difference is not so big. 159 to 178 is roughly 10%. But if you look at on this graph and don't think about the numbers, it will look like it's 40%, 30%. It's so amazing that I don't even have to consider everything else. And this is a usual marketing strategy. They put the right numbers, but they, hello. Okay, somebody is not muted. If you have a question, please ask. And thank you, everybody. I started with 18 and now I have 36. Thank you for joining. This one is much bigger than all the others. And this is what I wanted to say about pie charts. This is your European Parliament party breakdown. And I didn't put numbers on the pie chart. And second effect, I used 3D. What is my thinking when I see such a visualization? Well, these guys in red in European Parliament and these guys in light blue, are they that much different? Well, not really. This is big. It gives me a 3D effect. This guy is far away. It's in blue. In reality, this is around 20%, and this is around 38%. The areas in pie chart are almost double. But visually, when you show it like this, you again put the right numbers, but you were trying to fake it by 3D effect and by the pie chart. I'm not that much worse than my competitors, but I'm not hiding anything, but I'm not also showing. A difference on a bar chart would be obvious, but he on purpose did not want to present it on a bar chart, then it would be clear. The newspapers supporting S&D created it like this, with a message, the results of elections were not so bad, look at us. But if you would put it, and of course in the article, it was written that this is 40% and this is 25%, but nobody reads the article. Everybody remembers the visualization. And this is how you fake visualizations. And this is one of the bad principles. So when you see a pie chart in the future, try to understand that probably somebody is hiding something. A long time ago, and this is my last example before the break, there was a site. This site was called OkCupid. It was before Tinder, it was before all these dating sites. The site doesn't exist anymore, but with a simple Google search, you can find this data set. The owner of the site, when the site went down, exposed the data set, of course, fully anonymized and everything, from the website. And it's extremely interesting to do data analysis because it shows women behavior. It shows how women treated men likes and how men treated women likes. And there was also a category how many of them actually agreed to meet. Of course, it's fully anonymized. There's no private data in, but it's used quite often for social research. And then one of the presentations, you can also find it on Google. If you put this one is from Google, by the way, this picture. What it tries to tell you, and this is a fault of averages, is that ages of women from 20 to 50 correspond to their interest to the men, except in later years. So who women liked are men of approximately same age until they would reach age of 42, and then they would stop at age of 40. They would like younger men, but only after age of 40. The issue with this is the average. Average can hide enormous amount of data, which is below average and above average. But if you read this graph, and it's not explicitly said that this is an average, not a whole data set, and this is, by the way, an average, you would go with the message that all women prefer guys of the same age, which is false, because you have a huge data set which you ignored by average. On the other hand, to be fair, I put also the other way around. You would say that men always like ladies in 20s. And this is a data set of around 50 or 60 million people. This is, of course, fake. This is the average. And then you could construct a message that all men like only ladies of 20, which is, of course, also false, because average can show up to 50% of data set. Everything above it, you just lost half of your age group. It might be true, but it might also hide. And this is a very explicit example, because it's close to everybody when I show it, is that when somebody shows something with an average, you have to ask what he is trying to hide. Same with pie charts, averages hide things. Do not use an average if you want your audience to see the real state. It can show you a tendency, but it doesn't show you the real thing. So analyzing data sets of social behavior of people by using averages actually shows you very little. I will make a break. Please type me any questions. Now it's 12:54 until 3 p.m. We finish with dashboards, and then next 1.5 hours we are in Python. If you have questions or something, please write them to the chat. Thank you. 5-minute break. Okay. Thank you for your questions. I do not know how much history you see in the chat. If somebody's joined later, this is the link for the materials. The materials are 3 books, and you have the slides, and you have Python cheat sheet, and you have the code, which we will show later. So I will finish with the dashboards now. And then we will make another break of few minutes. And so I start the Jupyter, but really few minutes, and then we do the code to the end of the session. So dashboards. For dashboards, you have a book. An entire book is written by Stephen Few. It is on dashboard design. It's not a big book. It's 166 pages, so it's not that terrible to read. But it's important if you are interested in the design. And here you have a lot of topics, which I already discussed today, about excessive detail, colors, meaningless data, encoding quantitative data inaccurately. This is what we were showing with pie charts. So overusing or misusing colors. So this is actually a hand guide how not to make mistakes or lose your audience. So if you are interested in this topic, and if you remember, I showed proximity, similarity, enclosure, and closure. We didn't show continuity and connection. We also didn't show attributes of color because it takes more time than this lecture allows. But if you want topics of color or everything, just read it here. It's with some nice how to do properly dashboards. And if you are interested in later in dashboards, the person did it for detail. So it's for salespeople and also on C-level. So this is different audience. Salespeople want to see one thing. CTO, CIO wants to do something else. Marketing wants to do something else. And these are the by the book examples. But as a small intro to the topic in the time we have, I want to discuss a little bit what are dashboards. And dashboards are visual displays, pure and simple. It's a separate field. They display the information needed to achieve specific object. Like on a visualization, do not put more than needed. It has to fit a single screen or a tablet or a monitor, and they have to monitor high level. They have to be understandable to the audience. If your audience are IT guys, they will understand differently than if it's a medical person or a social worker. It has to be concise to the audience. They're customized. It's not the same for CTO or salesperson. And it's a type of display, not technology, and it doesn't matter. In a bigger round, I would show tools from the history. So Cognos, business objects, Excel in the versions of 95, and then I would show the tools of today, Tableau, Power BI, new Excel, Office 365. You would see the interface upgrade because it looks better. But the exact principle didn't change for 20, 30 years. This is the dashboard. This, what you see on the screen, is a dashboard. It's one screen for the tool of your choosing, and this is how you use the space. If you were a small child who passed the education in Western Europe, you would know that you read a book from top left corner. And you are used to the fact that everything begins in the top left corner and ends in the lower right corner. This is the basics of dashboard design. The most important things go to top left corner. Most unimportant things go to lower right corner. Neutral positions are lower left and upper right. And emphasized is the middle, because we are always taught historically that the most important thing is in the middle. If it's a pyramid, it's top of the pyramid. If we have an org chart, the CEO is in the middle top of the org chart. It's always the middle. Even if it's 2D, 3D, it's always the middle. So how does it work? I will show just one dashboard. And this is a CRO dashboard. It doesn't matter in which tool it was created, but this is a dashboard which is done by the book. This shows all the best principles of dashboard design. And I will spend about 5 minutes to go through it. Remember two important topics. This is the most important area. This is the least important area. And these are neutral areas. And you are a CTO. And you are a CTO of, in this case, a big website, which has key information when you log in after your first coffee. What is the key information for CTO? Does everything work? No details, no projects, no nothing. Does everything work? In two categories, green or red. There is no yellow here. I need to know as CTO while drinking my first coffee, is my system working? What do I see from this dashboard? There is a problem with data warehouse. I don't know which one, but there is a problem, which means I do not have to care about website, email, network, or ERP. I can continue drinking coffee, but I need to call the guy responsible for warehouse. But before I call the guy, I need some additional info if I can get them. So my eyes go down. What do I see? This is a special type of bar chart, which is out of, it shows three things. Usual bar charts show only one, the length. Here it shows complete 100%. It shows average, which is something like this, and shows current state. So what I see here, the data warehouse is 93.2%, which is whatever this number means, availability in this case, it can be something else. It's below the average. All the other things are inside the average, and network and ERP are just below the average. If we are discussing availability and it dropped, it might mean that maybe network is at fault or ERP took most of the resources. What do I have? With one look, it takes me 3 seconds. If I know how the dashboard looks, I know the state of my system. And that is in the top left corner. This is a CTO dashboard. I do not need the details. When I understand what is the problem, my eyes go to the neutral area. Neutral area is key information not related to main categories, which is CPU and storage in IT world. CPU is 79%. It's still yellow, but I might take a look after lunch on this one. Then I have daily network traffic, which shows me 3 lines. Daily mean for last 6 months, daily mean for last 7 days, and yesterday. I don't need more info. I don't need pop-ups. I don't even need exact numbers. What I see that yesterday was well above the daily mean for last 7 days. That's the only info as a CTO I need. Nothing else. Combine it with availability of data warehouse, combine it with possible network issues, and I have a full overview of my IT system. And then there is a response time, which means on data warehouse, ERP, web, and HR, I have the lowest response time, which is actually okay-ish, because internally, HR system can have a longer response time, but my ERP or DevH might have. So no issues here. What is acceptable, we can discuss. This is a business logic, but I don't see any immediate issues here. Then go to the next neutral area, key non-system metrics. Now we are forgetting IT, but as a CTO, we are going to money, expenses, customer satisfaction, and level 1 tickets. Expenses are something, customer satisfaction is something, level 1 problems is something. Again, I can, however I define these colors, this is your decision. Is it average? Is it in last something? Is it percentage? But if I know what is on this dashboard, I see immediately the state of my expenses. What can be is that this line is a baseline, this line is current, this is some average, but you cannot, and here is a legend, so actual, good, excessive, critical. It takes you maybe a few minutes to understand it for the first time, but other than that, you have a full vision of your IT company. Then we are going more and more to the lower right, which goes to less important topics, but still important that you know about them, but not critical. So I have development projects, major project milestone, and I see that budgeting system is in red. I don't need more info. I just know it's 3 weeks or 2 weeks overdue, and I need to call somebody. Then I have 5, this is now going to almost not important area, but it's FYI for your information. 5 top projects in queue is something I would like to in generally know, but I can skip this knowledge compared to the red state of data warehouse. And the last one are critical events. This might be level 1 tickets, so problems like something, or even less important are key events from your calendar. Tom visiting from Asia office, prepare quarterly financial. This is a to-do list. And to-do list compared to failing data warehouse, of course, means a completely different thing. This is by the book design dashboard. How it will look in your exact example, it can be different. The tool will be used differently, so the entire GUI will be different. But this is how you design an effective dashboard. Top issues, explanation of top issues, secondary non-top issues importance, FYI as we go down. If you would put critical events here and system availability here, and you open the website in the morning or whatever it is, tablet, your eyes would first fall to my events. And then maybe after I understand that Tom is visiting from Asia office, I would understand the data warehouse is in red. If somebody designs your dashboard in this way, then he doesn't know what he's doing. Literature, sorry for the typo. There are 3 books which you need to read if you are interested in this area, and you do need to read them. It will not help with a quick online course. First one is a TAFTA, the visual display of quantitative information. This is non-tool related, non-vendor related. It's a list of concepts. The second one is from Albert Cairo, The Truthful Art. He was a newspaper guy, and he is showing how newspapers are lying, or let's say showing the things, still showing the correct numbers, but hiding them inside visualizations. He talks a lot about dashboards. He talks a lot about header visualizations in newspapers, which he also calls the type of dashboard. But he's talking about, in general, how truthfully show data. And the last one is Stephen Few, Information Dashboard Design. It's a book which I opened for you. It's basically step-by-step guide how to do correct visualizations. Again, non-vendor specific. It's a set of concepts. So now we have to start doing something, and I will start showing it in Python. And we will go to three topics. And my time with you is until 2:30, and I will, I think, fill the entire slot. What we will do is we will do exploratory data analysis, but I will not execute it. I will show it in Jupyter Notebook, but not to lose time. Again, all the Jupyter Notebooks, all the code, everything is in Google Drive. But I want to show you the results, and I want to comment the results. You can click execute for yourself. Second of all, we will do data design. And third of all, I will show matplot seaborn as beginning. And then I will go to plotly and advanced. And advanced is really advanced. So I do not have, I will cut at 2:30. But please take a look on everything in the notebook if we do not have time. So finding the store in your data. And this is for everybody who is in data science quite clear. For those who are not, I will, there's like 3 or 4 slides here. Too deep. But if you get an Excel or a CSV or whatever you get, and you want to start analyzing it, and you need EDA as a first step, and you always need EDA, you need to understand at least implicitly 3 concepts: trends, correlations, and outliers. So trends, is your data going up, down, is it stable, whatever? If it's age, my age can only increase, I cannot go younger. If it's sales, it can go up and down. If it's gender, it has only a couple of choices, blah, blah, blah. So this is what you need to understand. Correlation, what is correlated with what? At least on some intuitive level. And outliers can be extremely important, and you cannot dismiss them in some areas of industry. Cancer research, you actually are looking for outliers. Banking industry fraud, you are looking for outliers. So this is what you need to understand about data. And I'm not going to talk trivialities like integer floats, but you do need to know what are your data types. If you do not know it, you cannot do analysis. You have to understand if they're quantitative, continuous, discrete, or categorical. You will fix your machine learning analysis differently depending on the type of variable we are discussing. And of course, relationships, time series, correlation, nominals. Like I said, I will not go into details. I expect that the audience here knows these things, but I wanted to keep them in the slides for the completeness. Again, ranking, deviations, distribution, part to whole. Part to whole is sometimes understated or let's say forgotten, but in some industries, it's basically the most important thing you want to do. And again, I wanted to just from the visualization part, I always stop on this slide, is that this little piece of pie, which is extracted from the entire pie chart. People like to say we have our customer groups and then one customer group is special because he will get special things, blah, blah, blah. And this is good. But there is another case when you want to show this extracted group as more important than it is. The first one is a valid representation. The second one is lying with data. Because if you look at it like this, you can get a feeling that this dark yellow compared to this red is actually much bigger. But if you would put this slider back inside, this can be only 1 or 2% in size. So depends which message you want to say. If the message is, this is our special group of customers, we take care about them specially, it's cool. But if you want to say, this is a large box, which actually like this looks larger, almost equal to this one and significantly larger than this one, then we are lying with data. So these are the small tricks people use and you have to in time learn to recognize. Best practices. And this is a topic which I had a question from Istvan and I forgot I kept this slide, is colors. Colors depend on your personal IQ. Most people of average IQ distinguish 5 colors on any visualization. And if you put this to, this is from Tableau, but it can be from any other tool. You put countries, so this is a list of countries, and there is something which we want to show about country, and you get this. Your brain goes into a block. This is totally not useless. Then we categorize them in 4 categories, but still leave the same amount of data points, and we will have a lot of colors which are similar. This brings again nothing. So if you want to show really a lot of data, you have to show bar charts. And here we minimized to maybe a heat map from red to dark blue, but your brain is no longer fighting it. We still have a lot, but compare this one to this one. This one is much easier to read. With a small change of how we visualize, we can get much powerful message across. The answer, again, which was a question, the complete hue, this is a name for clean color. So red, blue, green, and something, they do not exist in nature. Clean color does not exist. It's artificially created by us. There is no clean red. If you put clean red, it's a warning, because from the old age, red is danger. Do not put clean red on a slide unless it's a warning. Put orange. Orange exists in nature. Put some kind, but if you put clean primary color, they do not exist in nature, and your brain will understand them as artificial. This is evolution, nothing else. So use 4 to 5 colors and use only the colors which are natural. Clean colors are outliers. And next, orient data so people can read it easily. Vertical text, unless you are you come from a background of Arab countries or Eastern countries, is not what is natural to humans of this part of the world. As soon as you put verticals, you are suffering. Your brain is suffering. Don't put verticals on numbers. Don't put verticals, and don't try to show 3 categories: time, something, and something. You will talk and the people will still tilt their head to the left to read. If you need to show them as we are in, at least in this part of the world, used to. Main category, subcategory, third category, horizontal values, horizontal bars. What else? And this is, I will not go one by one. I leave you the slides. And these are a summary, so 10 of them in total, what not to do on visualizations and what to do. When you start doing a lot of visualizations, these things will start coming naturally, and you will start doing all of these things. But in the beginning, in the educational learning time, you have to force yourself, and some things might not be natural. But as you do more and more of them, you will just start to do them automatically. I'm keeping the best practices here. And number 7, don't use 3D charts. I already showed at least 3 examples how we can fake data with 3D charts. One more topic, don't use distracting fonts. The fact that you have installed 20 fonts doesn't mean you have to use them. If your brain subconsciously detects a different font, he will take it not as a nice graphical add-on, he will take it as an error, as an outlier, because our brain works very attentively. It looks for patterns. The fact that you can do bold, italic, and underline is only like the red color in the case of message. Because it looks nice to you, it doesn't look nice to the brain of your audience. So let's go to code. So I have my virtual machine. And in my virtual machine, okay, I hope you hear me well. It doesn't seem too bad. In my virtual machine, I already have examples opened. And all of these examples you find on the Google Drive. I will run the executed ones, so we don't spend time on executions. Data sets, I took multiple ones. I took the standard Boston housing Pokemon because they are easy to do. But I then did in advanced and EDA, I took a challenge from, I complicated things a little bit. I took a challenge from online and something. So let's start from the simple things. And as we go on, things will complicate. Now I'm looking back to my chat. Do you guys need another 5-minute break, or we can continue? If you don't say you need a break in next 10 seconds, we continue. If somebody needs it, we'll make another 3-4-minute break. Does somebody needs a quick pause? Okay, nobody wrote anything, so I'm continuing. Good. So open it if you have it. If not, I'm still sharing the screen. And what will you see in these Jupyter notebooks is a lot of explanations on purpose, so I don't have to read from the slide. I leave you the materials and you can read them in your own time. This is an intro, and this is an already executed intro. And I keep a lot of text here, which I will of course not read to. But this is a summary of what is data visualization and what we can do in this field. And there is a lot of comments, and the things which I will not say you can read later. I will start with matplotlib. Everybody, hopefully, at least at some point, use this library. And it's the most usual library when you start doing data visualization. It's easy, you use it as NumPy, it's customizable, and you can do really a lot of cool stuff using this library, from the very simple things which we will start with to quite complex calculations. The benefit of this library is that you can really customize it a lot. There is a lot of templates, and the online documentation is really good. So we start on a basic example how to use it. We start with just do me a simple line plot. Give me two values for X and Y. This is a normal X distribution. This is a sinus function, and show me the function. And this is all there is to it, to showing the most basic graph in matplotlib with X and Y axis. That's it. Second, which we will use quite often, is a bar chart. And bar chart shows in the most simple form. And what I'm saying is always here in the description, so you don't have to remember anything. I'm not using any data set here. As you can see, I'm just using at this moment red, green, blue, putting some randomizing and creating a basic bar chart. Again, no coloring, no labels, just the most basic one. These are the two you will use most in the beginning. The third one, you need to use a histogram. And there is a description what is a histogram. But in short, it shows a distribution of data. Since I'm using a perfect random distribution, I will get a perfect Gauss distribution. Of course, in the real world, you will not get such a nice graph. But now I'm just showing you the simplest examples. So line chart, bar chart, histogram. Then what is not so often used in business applications are box and whisker plots. Box and whisker plots are a derivation of histogram, and here's a full description. But except showing you the percentiles, so 25, 50, 75, it also on one graph shows you the outliers. So it might not look so visually appealing, but it actually shows you much more data. You can see the distribution. This is a turned around histogram. So the main part is in the middle. So this is again an ideal distribution histogram because we have ideally randomized numbers. But in this random function, we still got out of the left and right percentile size some outliers. So on one graph, we see the distribution in the histogram form, we see the size of percentiles, and we see the outliers. Quite useful in things that we will see. This is the fourth type of graph. The fifth type of graph we will need is a scatter plot. Scatter plot is a simple distribution of points. Again, I'm using a random function, so it looks ideal. In the real world, when we load the real data set, it will not look so ideal. And these are the 5 graphs in their most simple form. And in your EDAs and in your discoveries, you will use all 5 of them. Now we will start to complicate. This is just the hello world of data visualization. Now we will start to add complexity. EDA, exploitative data analysis, and this is a true comment, is often overlooked. We do it, but we do it like, yeah, we have to do it. Let's get over it and let's get to our nice little models. But actually, it's a mistake. Because from EDA, we can get an enormous amount of information, which I will show just now on 2 examples. Tutorial 1, tutorial 2. Boston housing I'm using because most of the people, everybody knows Boston housing because it's a very often used data set. But I took the case from Kaggle and I increased a little bit the complexity later. So how does it start? And this is an EDA hello world. Since Boston housing is quite simple, I will do another EDA, which is a more complex one. But for people who never saw an end-to-end EDA, this is an important lesson. So idea is you get a CSV, which looks like this. And it can be whatever CSV in your world exists. And this CSV, which I do not see on my main screen at the moment for some reason.
It's in the right corner.
Thank you. Yeah. Shows you actually nothing. You do not have any idea what is this. This is some housing data. It can be banking data. It can be telco data. You have no idea. You have some numbers. You have some column names. They mean nothing to you. So how does it continue? Okay, after you load the data, after you put some kind of format. You first like to see what is inside. You are not really more, how to say, more smart now. If you know it's housing, maybe text is housing, maybe something is black, you have no idea, you have some age, you would guess this is maybe age of the building, but you are not really sure, and you have no idea what are the data, what is the other ones. So you start, usually, by checking nulls. If you did any analysis, you know you need to handle nulls. In this case, which we are showing as tutorial 1, it's a perfect data set. There are no nulls. This will never happen in real life, but you need to check for nulls. In the real world, if you have nulls, you usually have 2 strategies. One is to replace them. But the issue with replacing is that if you replace them by -1, by commas, by whatever, is that if you model on them later, they will be real values and they might destroy your models. So you always have to remember that you exclude replaced values. If there is some threshold which is achieved or overachieved, which is like 75% or more, then the good strategy is to delete them. But this depends on the business case. Delete entire column or exclude them from analysis. We'll do it on the next example. But now we made sure that there is no null values. Secondly, renaming. Renaming means sitting with the business or whoever sent you the data set and actually understanding what this column means. It looks trivial, but if you continue analysis with Indus, whoever goes later and sees your model will not understand. So you either do it now or you do it on a reporting level, and I can tell you it's much better to do it now. So would you connect Indus with business zone percentage? Probably not. Again, maybe you do not know what this means. I do because I was doing this case, but in this case, it means what percentage of real estate of ground is in business zones. And for some people, this is great. They might live close to business, but for some people, this might be terrible if they want a nice, calm district with not much traffic. So RM are average rooms and so on. So you do the name, so your data set looks a little bit more decent. Now we have to start with summary statistics. There's still no data visualization, but it will start. Then start with summaries. So what do we have? And now this look can give us some info. For instance, this one we do not understand implicitly. We have 23, then we have 0 there. But on the other hand, the rate of crime is a little bit more understanding. If the business told us, this is, for instance, the number of muggings or murders per, I don't know, 1 million or something. This can already give us some kind of feeling. But this one, I have no implicit knowledge, oxide concentration, nothing. But on the other hand, average rooms is the number of rooms in the apartments or buildings or houses. So in this district in Boston, I can say that I have a mean of 6.2, standard deviation to 0.7, which corresponds quite nicely to these numbers. What can I guess? That maybe this is a H district which has apartments or houses with a large number of rooms. So maybe I'm in a good district. Then we have a matrix. Now I'm not going to go into detail, but I'm showing you the importance of this initial phase. It can gain you a lot of understanding. Secondly, distance to work. This is in miles. These are the people who bought something expensive, but still want to live quite, for US, this is close, still want to live quite close to their work. 3.2 miles in US is not a lot. And so on and so on. Now, when we are done with this step, we have a case, and I put a link to the Kegel study, but let's say I wanted to use rate of crime. And the rate of crime, I get a box plot. You already saw it. I just put it in vertical. Now it's in horizontal, because this is how seaborn does it. We still didn't go to seaborn. We will do it. What do we see here? There's some kind of outliers on the right side. But on average, it looks quite okay. There is nothing much. There is from 0, and there's a lot of them here. So rate of crime is quite low. But on the other hand, distance to work is much differently distributed. There is more between in the right zone of percentile than in the left zone. So if I'm buying a flat or an apartment here, there might be apartments which are more distant than I would expect. And there are some outliers that something is more than 10, whatever, kilometers, miles. Then I see, okay, these are my main parameters, and these you get from your real analysis. And now we are starting with visualization. But I want it over everything. Let's say I want it over everything. And now I'm showing it on my laptop screen. But if you would have a large monitor, let's say normally a 27-inch with ultra HD resolution, which really pays out here, you could stretch this image a little bit more. But on one view of one box plot, you actually see an enormous amount of data about your data set. You see distributions over all variables. Now, I know it looks ugly here. I apologize, I cannot show it bigger, but you can stretch it on a bigger screen. Of course, you don't have to do it over the entire data set. I melted the entire data frame. You can exclude some of the things, but one nice view to do in the beginning is over everything. Maybe I find something interesting. When I'm done with this one, what is a good practice is to do something called correlation matrix. And correlation matrix you can do by hand, you can do by numbers, you can code it in Python, that's not a problem. But what you should do is a visual display of a correlation matrix. Please be aware that these kinds of things on a bigger data set can last quite some time, even half an hour or more. So be prepared. This is what I'm showing in an executed format. And from this visual presentation, which again, you can do numerically, but here it's much more attractive and easier to see, you see some important relationships. Again, what you will analyze depends on your case, but what you, for instance, can see is, I'm just now guessing, business zone percentage over distance to work, and it's negatively correlated. So they're going in opposite ways. Again, not all of these numbers are interesting to you, but you can visually see some really things you do not see from the CSV file, you see visually. Maybe you missed that oxide, sorry, I already went to this one. So some extremes. It doesn't matter if they're in plus or minus, but maybe some extremes that you were not aware of. And you can also focus on the variables you are looking for. And now from this one, I want to analyze, for instance, on median value. So it's the simplest one, it's money, it's price. And I want to focus on only one value, because this is what I want to research. I then can take it out numerically. But from the visual image, I see the entire data set in an overview. And then again, on your bigger screens, it will look much nicer. If you want to visually connect linear relationships between one-to-one each ones, Seaborn will allow you, and I know that it looks quite not nice. I would need a bigger screen, but this is each with each. And each of these graphs, this font is very small. When you execute it on your screen, it will look nicer. Actually gives you a relationship from each variable to everything else. So in this case, I have 16 variables. So it would be maybe prudent to exclude some of them from the data frame before doing this. But if you want a nice big wallpaper and see visually how each variable goes to everything, this is only for one variable, and this is for all 16. So again, some people like to read the numbers. Some people like to do it visually. If you want to simulate this one, which is in text, just exclude from data frame, which is used in SNS, everything except home median value. And this is the basics of EDA. Usually you stop here, usually, unless you have a specific case. But now try to think that you didn't do it. You are still stuck with the CSV. You have no idea how things are correlated. You have no idea how they are linearly affected. And you have no idea what is the variable distribution. Skip this step. And it's really trivial to code if you have it in a data frame, and you will lose a lot of insight. Now let's go a little bit deeper. This was basically using the default settings of everything. Now let's not use default settings of everything. I will go with matplotlib, and I will start with one example, which I will build over the next 10 or 15 of them. It will constantly be the same numbers. I will just build upon the visualization additional things you might use in the future. There's a simple explanation here. What are all the objects in matplotlib? You should read them to understand. And if you will want to customize, you will need to understand these things. So I'm leaving it as comments, and I will not read them on the lecture, but go through them. So how do we start? Matplotlib, same line, 1, 2, 3, 4, 1, 5, trivial line. Let's start upgrading it. First thing which we will usually need is some labels. We will need to put some kind of labels for our audience. You have a title, X label, Y label, same trivial graph, adding labels. Good. Thing done. Now, if you want to extend it, it's in inches. So you can add a figure size. And now I'm adding the width and height in inches. So multiplied by 2.54 or something. And this is a physical size of the graph. In inches. So same graph, just hard-coded size if you want to target a specific screen. Then, if we do not want a line, we can go to the documentation of matplotlib and find literally dozens of templates. So I do not want a line. I want dots. Same data, dots. I put a template goal. If you want something else except dots, go to documentation, put another string. You can have circles, you can have triangles, you can have a TD, whatever. Just use a template, different one. Example, now, if I would put here, so I can execute something, if I would put here, for instance, this template, he would give me, yeah, it will not work because I didn't load the data, or I did, let it happen. If we want to show two lines, yeah, now I got triangles instead of green dots. If I want to show two things on one graph, and this goes back to reading what are x's and everything from the beginning, I create now two functions. One is 1 to 5, the other one is to third potential, and I can add multiple visualizations, multiple kinds of visualizations on one graph. I can add more, I think up to 16 or something. Yeah, just add, so pair X function, Y function, template. Everything else is the same. Then we want more on our graph. We want multiple plots. So we want to show multiple things. Again, I'm using the same templates, same functions here, same templates, but I want to show them not on one graph. I want to show them in parallel. I'm using a name called subplot. So I'm adding two plots on one plot, which means it's in one row, two columns, in one per item. You will see that I left it in the comments what this means. And I'm creating two separate plots and just showing them. And I have a general title, my subplot. If you want more, if you want to reverse them, you say, I want two rows and one column, one per item. So same code, same everything, one to the left, one below. This is how you put things together in matplotlib. You can put as many as rows and columns you want. If you want to put empty placeholders, in this case, I'm putting it hard-coded. This is a different syntax. I put a number of rows, number of columns, and I'm putting a hard-coded size of 6 inches. So 13, 14 centimeters, but I'm filling only two of them. I'm filling 0, 1, so this one, and I'm filling 1, 0, this one. The other two are empty. There might be a reason why you want to leave them empty. But like this, basically the simple matrix addition, you can add as much graphs as you want. Now, let's add different ones. This is basically a line chart, just with different visualizations, not a line. Now let's add more. I want a bar plot because I don't want states. This is a state graph. I want my population distribution. So I will not go into syntax. You have it. It's basically trivial. You just, instead of plot, you use a keyword bar. And you can see in documentation, you put categories, you put values, and it draws you a bar. And again, there are some templates involved. If you want to reverse them, you have to read this documentation for these methods. You also accept the value vertical. You can put horizontal ones in categories. You put values, but you also show the variance in color green. So this line is a variance. Then, and I'm going to a lot of examples, so you have it, but I will not go to the syntax. You can read it yourself. The next thing I will need in my EDA when I go into more complex things is I will want to show multiple categories. And I want them stacked horizontally, but remember what I was saying when we were doing the intro, all the text should be horizontal, not vertical. Some people even avoid to put this label here just to avoid people brain to read vertical text. And there is a little bit of legend. How you did it, again, same story, same data, you just added a little bit. So this is the title, horizontally stacked bar chart. You have index plus width, which means I want my blue one 0.3 inch to the right. So this is how they look. If you don't want them one left from the other, but sometimes you want them like this, you do not put this plus. And then they will be one on top of each other, not one left or right from each other, but one on top of each other. It's basically everything else is the same. This is how you want to do bar charts. Then let's go to pie charts, which I said you should use quite conservatively. It's the same, you just click pi, there is some kind of parameters, and then there is this explode one, which we will comment. Labels is clear, shadow is just a 3D effect. Here, it's borderline okay to use it because it doesn't degrade the entire image, but this explode, again, you have a feeling that it's bigger than it should be. So in this case, I can say, I want to evaluate this company, and then I'm presenting, and from now on we will focus on company B. But in this case, if we want to state it as this is the best product, it looks exactly the size of A, but actually might not be. So these are the two scenarios. You want to point out something or want to lie a little bit with the data. But this is how you make a pie chart. And there is not much more, how to say, there's nothing more to it. You just add categories, and of course you have other templates. You just add them from documentation. Then histograms. Histograms are again very easy. You put some values, you make a histogram. And now we go to 3D. 3D requires you that you have a third dimension. And it starts with first scatter plot. We need to have some kind of distribution. So plot is usual scatter plot. Again, you can add it in documentation. You just give it fields for X and Y, you draw it. But this above can be visualized in 3 dimensions. So you want a scatter plot, not only of 2 values, height and whatever, weight. You want a third parameter. The third parameter is given by a template called projection 3D. This one is quite small because I don't have a lot of values. But be careful if the 3D effect is what you are targeting for. Because if I would take this dot, I'm actually not really sure where it belongs. It looks like it's around 170. It looks like it's around 75, but where does it hit on the Z-axis? It can be minus 0.02, but if I draw it, it can be also 0. So adding a third dimension is usually not adding to the end user. It looks cool, but might not add it. In the later examples, I will show you in an animated 3D, then it makes more sense. But a hard-coded 2D, so 3D, but hard-coded might not give your audience something. And this is the limit on which I will go to matplotlib. These are the usual visualizations. All the other ones, which you saw in this library link, which I show you, are always the same approach. You go to the documentation, you find the keyword, and you put some parameters. Usually these parameters are some kind of template in X, Y, and some labels. If this is too complicated, if you don't like these templates, if you don't like this kind of attributes, there was a library developed, which is called seaborn, which is built on top of matplotlib. It actually includes matplotlib, but it's made to be more simple. What it lacks is customizations. You get what you get. And I will show you, it's a Pokemon dataset. And the Pokemon data set I really like for now multiple years. It gives you all the cartoons from my youth with abilities from all the nice Pokemons. So if you remember, there were seed Pokemons, then they had some powers, then they had some characteristics, there were dragons, monsters. I always like to use this one. And it's really cool for visualizations. What I will do is I will show you another EDA of, in this case, Pokemon, but using seaborn, not using Matplotlib. How we use it? Again, we have to use Matplotlib. It has to exist, and we use seaborn. We load some data. Again, we do the usual. Let's see what's inside. But I will now start immediately with plotting. So let's say we fix the null values. Let's say we fix the numeric stuff, but this is a visualization lecture. Let's start with what seaborn can do. So I want to start with a default line plot. And if you remember Matplotlib, if you would put plot line, it would give you a line, nothing else. Seaborn immediately gives you trend line and area, not confidence, I'm also talking too much. Okay, gives you area around 10 line. What I wanted to say is you cannot much optimize this one. You get what you get. If you want to add things, regression line, Jesus Christ. Okay, sorry. If you want to optimize things, you can add parameters, but this is only what is available in the plot. You cannot add additional templates or something. So I don't want a regression line, and I want color, here is color, defined by the column status. So what he does for me, he does me a chaos. This is not that much useful. I'm just showing possibilities. He adds me a legend. Okay, attack and defense I defined, but the fact that these are dots and I get a legend, I don't have to code additionally. Then customizing. If I'm not happy with what Saban offers me, and this is easier to use for people with less Python experience, as there is a matplotlib in the background, you can still use the seaborn, but included in the seaborn is below matplotlib. So you can tweak what you got from seaborn by customizing directly in matplotlib. So in this case, I will just increase X limitation and Y limitations just for the fun of it. But what I'm showing, you can use the underlying matplotlib to customize what comes from seaborn. This approach makes, let's say, little sense because we are using seaborn to simplify our code. But for some reasons, when we get a nice seaborn graph, but want just a small modification, then we use the underlying matplotlib. If we do a lot of customizations with matplotlib, then maybe we are not supposed to be using seaborn. Okay, we all know what is pandas. So in seaborn, I wanted a small introduction to pandas. Just for those people who are not about it, you can read about it quite nicely. And I'm now going to do it differently. I'm going to not call the method like I'm calling here. I'm using it from the other way around. And here you can again use the seaborn box plot with a data frame, and it will give you this. And again, you cannot customize it a lot. Again, my screen is too small. This one would have to be staged, and it's an ugly one. And now, as I said, we will start to do it more proper, and we will start to remove some of them. And we will pre-format the data frame, which we would like. And since the CSV has 40-50 columns, I will, as a first step, remove a lot of columns. And then my graph starts to look more reasonable because I'm keeping only 4 of them. I want something called a Pokédox, weight, hit points, and attack. So this is how you would clean up, but don't do it on the main data frame. You will still need it. Create a new data frame. But again, I didn't do no customization. The data frame, he did all the coloring, all these nice things. You cannot change it. But if you don't like what comes, there is a lot of themes for seaborn. And the default one is diagrade. And if you go to documentation of seaborn, you will find dozens. And you can download from community hundreds. So I'm really sure you will find something which you like, so you don't have to code your own. Now, for instance, I'm changing to a different theme called WhiteGate, and I'm using a violin. Violin graph I still didn't show. It shows the population, quantity of population is defined by thickness. I'm writing it here. You can Google violin plot. If you don't like box plots, they again show you distribution of data, but they are not by boxes, they are by thickness. Some people like this kind of visualization. Shows the same thing, just shows it in a different way, only of the variable generation. And we have electric, ground, ice, fairy, whatever. These are the Pokemons. And they're really nice. They're usually much nicer on a big screen than box plots. So next one, which I will show you, is if this is not good enough for you and you want more detailed data, you can use something called swarm plot. Swarm plot is like a violin plot, same logic. It just shows you dots. So it's not nicely formatted like this one, but allows you to see actually the number of population items. This can be quite tricky if you have a lot of them by category, then this picture will be, well, distorted. But if you have a limited number, in this case, electric ones on the attack scale, I have 10 Pokemons roughly. If you don't have that many categories, you might like this kind of visualization more because except relative size, this shows you exact numbers. Then, next step, if you would want to do something, is an overlay plot. Maybe you want both of them. And seaborn is very easy on this topic. I hard-coded a physical size, so 15 by 6 inch, and I added 2 of them, SNS violin plot, swarm plot, gave them proper attributes, and just said draw. So no big, no subplots, no nothing. And what he drew me is this. He drew me a violin plot, but also included a swarm plot inside. You can do more. You can put additional ones inside and execute, but be aware that probably it's not visually too attractive. But if you want to add multiple plots in the seaborn, you just call multiple calls and he will put an overlay. And now it's a show off of seaborn. Show off of seaborn is what I can do with seaborn. And I will not go to quite detailed. You have this one in your materials. So mini gallery. If you want a correlation matrix, you use a heat map. You really just call correlation and call heat map. It will auto-generate everything. Same if you want a default histogram. Remember in Matplotlib we had to write something. Here, if you are happy with a default histogram, you call the distribution plot method and he creates you basically everything. You don't have to write additional code, but this is what you get by this template. or you use some other template. Same with pyplot. You just called number of ticks, you get a rotation, and you get this one. He sorts, you gave him a data frame, you gave him a physical size, you gave him a rotation of X labels, so they go like this, maybe easier to read than pure horizontal if there is too much text and not fully vertical. He does everything else. Color painting, labels, he does it automatically. I don't know if you ever see catplot. Catplots is a categorical one. This one might again fit on a bigger screen, but this one shows distribution by category. So you don't just have distribution by inside one variable, you have with multiple ones. And again, I just used you can use some other one than swarm plot. And a density plot, maybe you don't know also if you used it, it's quite cool how densely your variable is separated, and you just call a density plot and you see it. And if you want to multiply more of them, use a join plot on a data set, and he will maybe be a little bit creative. This one is by far the longest demo, which you can see by the time. All the other ones are much shorter, and I will continue immediately. If you lost something, all of the things I said and much more are in the descriptions, so you can aid upon it. Second one, as you can see, much shorter, and I will not go into details. I leave it specifically to you. This is a solution for the Kegel case, which is quite known, but I did it from the perspective just of EDA. And I increased a little bit the requirements. You can find this data housing on Kegel. It's not required in that case to do it so much in EDA. I added on top of requirements. So if you want, you go through it. What I did is I loaded a data set, displayed some of them here. You can add it numerically. Here is a link to the Kegel. It's in later stages, it's a regression technique, prediction of house prices. What I didn't go so trivial like in the last case. I went immediately to the point of what I'm analyzing. I went by sale price, by living and year. So I immediately focused on these two to get a little bit of a feeling of what I'm dealing with. So by year, it's quite obvious that the sale price, this is the year, so from 1880 to 2000, it's not actually increasing, which would seem logical, which means this is a rich neighborhood. And if you buy a house from 19th century or something from 2000, you will not pay much less for an older house. And sale price by living area, of course, quite logical. The bigger it is, it's more expensive. With some really, like you see that it's 5,000 square feet, which is more than square feet meal, and then it costs more than 7 million. So yeah, so this might not be expected, but this is expected. Then I want to see skewing. It's highly skewed to the left, but from this number I don't see. Let's visualize. And I'm looking now from the seaborn. I didn't do anything massive. I just give me a distribution plot on the sale price in 20 bins. So it's quite obviously skewed to the left. If I want to, I will not go into theory. If I want to equalize this, I would do a log distribution. You probably know what it is. If you want to log it in SNL, you don't have to do it in Python. You just use the log function. It's included in. So log distributed sale price. And then by the case, I have to look at 3 key variables. This is year built, living area, and state. I get a number of counts out, but for the fun, let's also take the foundation. Foundation is either wooden or concrete. And I edit another one. Again, I got just numbers, which is nice, but I want to visualize. So This is my visualization of states and materials. So most of them is pavement, and some of it is gravel. Gravel is these small stones. And so most of the states are pavement, concrete. Material distribution, of course, concrete or concrete blocks, but a small amount of wood and stone. So these are my variables which I'm working with. Let's see null values. So I'm looking at null values. I have some null values. Again, I get numbers. Numbers mean very little. I want to see how they are distributed. I see that most null values are in alley, pools, fences. So, and it's up to the entire data set. So what I would do, I would probably ignore or delete these columns because almost entire data set is null unless I specifically need outliers. So some numerical data, I put it in a transposed format. If you like numbers, you can see. And then I stole a function. There is a link to Stack Overflow there. And to write this, I am doing, and there's a lot of graphs here you will see in the code and an explanation. I want best correlations to the target variable. You can hard code it, but there is a function which is used quite oftenly, which does it dynamically. It's in the notes from Stack Overflow where I stole it. So this one shows the distribution of quality versus sale price, living area versus sale price, garage versus sale price. So I was playing a little bit with correlations here. And for this demo, that's the end. It shouldn't be the end of your EDA, but this is a demo of how you can do the usual things with seaborn. And in the last 15 minutes, I have even a shorter demo before we go to advanced topic. It's called Plotly. Plotly is a relatively new visualization. And if you do not like that web page which I gave you, there is another way to approach what you want to see. And this is this chart doctor. And yeah, the GitHub name is strange, but what he did is, except giving an enormous amount of content about how to choose a proper visualization, he created a picture, a big one. You have to download it. I cannot show entire one, which is a list of ideas of how you can use visualizations effectively. And again, as you can see, it's how to show part to whole, how to show spatial, how to show distributions, how to show rankings. It's your cheat sheet. So if you don't want to, let's say, go to that entire website, this is your list of ideas. It's called visual vocabulary. And now let's say we don't want it in Python. We have our website. We want it included in our website or PowerPoint or something. Then you can either export it directly from Seaborn to a file, or you can do it much, much nicer. How you do it, you use something called Plotly, which is very similar to everything. I'm using the same data set. But what it creates are not visualizations themselves. He creates HTML files. He creates visualizations, but already in the HTML file. And I will create a very simple scatter plot. Really a very simple one. Sorry, I need to load something. Okay. And now it will hopefully work. And when it's done, I should have here somewhere, it's not done yet, a HTML file. And if I would open this HTML file, it would be the same scatter plot like you already got used to. At some moment when he will open it, here's the scatter plot. But he adds some really nice features. You can include it immediately in any web page like this. It's one file with JavaScript in background. It has pop-up features. It has zoom in, zoom out. It has panning. It has auto scaling. It has a set axis. Plus, you can mark an area and it zooms in. And this comes out of the box. Basically, there's nothing else much to show. There's a different syntax. And with Plotly, I showed you a scatter field. You can also, I will run them. You can create box charts, or you can create heat maps. And there are, of course, hundreds of others. Now you get a box plot. Now you get a heat map. The difference is it's a JPEG in seaborn. And here it can be as a file included in any website or online presentation. And it comes out of the box. It's for free, of course. So if you need some kind of web presentation, use Plotly. And you still want to use Python. And now I will use last 13 minutes. And I will cut it to 30 sharp. And I will really start with as much as we go at 2:28, 27 to give you a few questions. I will cut and you then do the rest of it. This is advanced data visualization. We are going off the topic of easy stuff. And we are going into more advanced visualizations. We are using pandas, we are using Plotly, nothing that you didn't see before. We are just increasing the complexity. What we are reading is medium data. Pyplot is because it's a special format. Medium is Medium Inc., a very famous website for technical news. They are publishing their news publicly after some age. So this is from 2019. I think there's a 2-year back and they publish it publicly, but they have a special format. And to read Medium's format, you need a plugin called Pyplot. It's nothing so fancy. You read it and then you get a normal data frame with the data with Medium articles, and it's text of the article, title of the article. So it's the history of Medium.com website. But it's not about the complexity of the data set. This one is quite trivial. It shows categories. This one is about machine learning. This one is about education. I want to show more advanced graphs. So where do we start? We saw this one already. There's a histogram. You saw it before. It's a simple histogram. But now let's see percentage histogram. Percentage histogram shows not in numbers, but in percentages, the number of reads. When you use this pyplot functionality, you can immediately export it to web, which is very nice. You get, again, this kind of HTML out. So this is a percentage why this. Then what you might not have seen, and again, how to create it is basically just calling it with proper parameters. It's something called grouped histogram. Usually histogram are one valued ones, but in this case, it's two valued ones. So percentage of articles by time started and time published. If you want multiple category histogram, you can use this kind of syntax. Again, you can export it directly to Plotly. Histograms can also be overlaid. We saw bar charts overlaid. We can also do histograms overlaid. And they are quite cool if you want to show two categories, time published. What is a benefit here? You can also see overlaps, right? And you have on board and everything else. Again, I will not show you syntax. Syntax you can copy paste. I'm showing you options. Pyplot you already saw. There is nothing so fancy about pyplot. We did it before. But now we can also add frequency. We are not showing now numbers. We are adding frequencies. And this is calculated frequency, this doesn't exist in a data set. So if you want to calculate a little bit of tags, which is basically which category appeared, you can do it directly in the, of course, data frame and directly plot it. So there doesn't need to be a special data frame, then call a function, then do this or that. You can use pyplot as a part of a data frame calculation. Then, like we had histograms, we can do bar plots with multiple categories. Again, same story. You basically add a little bit and it goes in. Then what is possible is two x-axis. This is known from Tableau kind of tools. Here, not so usual, but you can use two y-axis. So you have here average views, and you have here average read time. This is not traditional graph, but it shows you for 1 point of value that on the date of January 2015, you had this much average views and this much read time. If your users are accustomed to this, it can save you one visualization, because quite nicely, you are showing here really a lot of things. Categories, two graphs. Standard box plot, which we showed before, this time with pop-ups, but now we can do multiple categories. So now we have box plots which have multiple categories with a lot of explanations. So I'm always starting from the simplest version and adding features. Then box plot of reads, again, now you have read times versus number of reads, distribution, seeing how it is over two categories, and even a legend. To add this kind of functionality is basically adding a couple of attributes. Then again, simple scatter plot. But in this case, I'm adding a time series inside the scatter plot. So it's a scatter plot, how value is distributed, but also with lines. And then you can create trends. So you have data points, but also a trend. So this is a trend graph, actually. If you need two variables, you can put two graphs by basically adding additional. So you have one, and then you have two. And what do we get? We have comparison graph. We have time series comparison graph. Remember my trivial example about income and costs from the slides. This is an income cost slide. Just you see now that it's maybe not so useful unless you are an analyst. What you would need is one line, but a difference between the two. So I'm now complicating my trivial case from the PowerPoint. Fans and word count, how many people clicked likes over sizes of texts they were reading. So a huge amount of information with claps, so likes, and word count, and you put a lot of it on one slide. Text annotations, if you want hard-coded ones, I don't like it, but this is how you do it. You basically add some HTML inside, and then you can put labels. I don't like it, but if you need it, it's there. Then numeric variables, scatter plot, this is the standard one, but if you want a fit, you get a fit line. You basically just also add something little inside. What else? Views versus word count. Again, you can have a line and you have a lot of data inside. This is logged. So this is a normal one. This is a logged distribution. Then we start with scatter plots, normal scatter plot, advanced scatter plot with two variables, three variables. So I'm just adding complications to the things you already saw. Then three numeric variables. If you don't like colors, you can also show it by size. So now you can see not only the locations, you see the size of distribution, or this is already a limit of people's capacity for variables, and it already is too much for one visualization. This is now shows an overkill. this is now a graph which is not readable and not understandable. So don't overdo it. Then you can put some limits, and I will actually stop here because it's 26. You can go to this. It's fully executable. As much as I go deeper, I just add complexity, and entire complexity is in the code. You use what you want, and we end with some really like even colorings and stuff, but use what you need. And for instance, we end with 3D. So thank you, everybody. My time is out in 3 minutes. And I have 30 participants who survived till now. I will ask if you have any questions. I'm muting myself. And please ask questions if you have them. Or write them in the chat. It's also possible. Well, if you do not have questions, you can find me on tomorrow afternoon on the panel session. And thank you for your attention. If you have any questions specifically, you have my contacts in the PowerPoint. Thank you all very much. And I'm closing 3 minutes early. Thank you all.
Okay. Thank you, Josip, Saban, for the wonderful presentation. Just a bit of info for the other attendees. We've ended this tutorial. You have about a half-hour break before the